Hello. So, in earlier lectures, we have seen what is a vector space. Okay. So, in lecture one, I have defined what is a vector space. Now, let's like we should improve the theory, and we should have more theorems in our hand so that we can do more theory. Okay. So, in this video, I'm going to show you what is so called the cancellation law for vector addition. Okay. So, So as you can see in this, if x, y, z are vectors in vector space V such that x plus z is equal to y plus z, then x is equal to y. Okay. And what is the proof? There exists a vector V in V such that this z plus V is equal to 0. Okay. Z plus V is equal to 0 means like this I have taught you, right? Uh, for every vector V, there is something such that this is called the additive inverse. This is in vector space, right? By the assumption of a vector space. Okay. So if this holds true, then x plus z plus v, this I'm adding to y plus z plus v. Okay, I've added v both the side. Now v plus z, this is equal to 0. And now y is equal to 0. So this is equal to x is equal to y. Okay. So this does the job. Yes, this does the job. Okay. Because x plus 0 is x and y plus 0 is 0. This is also, what is this, additive identity, right? Property of additive identity. This one, this j exists because this is additive inverse exists in a vector space, right? This is all these are discussed in lecture 1. Okay. You can refer lecture 1 to definition of vector space. Okay. So just wait for 1-2 minutes. Next, I will show the vector 0 and vector y. That identity, this identity 0 and this additive inverse, this are actually unique. Okay. So okay. So how do you describe this one? Okay. So we have that x plus 0 is equal to x for all x belongs to V. Okay. This we already have. And now let's say, first let's say there are 2 0. Okay. So then x plus 0 dash is also equal to this. Okay. So there are two identities, let's say 0 and 0 dash. Okay. So now what I need to show, 0 and 0 dash are equal. So how to show that? This is fine, right? X is equal to x plus 0 is equal to x plus 0 dash is equal to x. Okay. Mm, this I need to show. Okay. What do I do? Mm, Okay, okay, okay. So we equate both this side. X plus 0 is equal to x plus 0 dash. Okay. And then we cancel both the side. We can cancel it by this property. Okay. This theorem, cancellation law. Okay. So when you cancel it, this will become 0 is equal to 0 dash, which we needed to prove. Okay. So that's the proof of corollary 1. And let's do corollary 2. When I say VS3, it means the axiom 3. Okay. Okay, the vector y is unique. So what do we do here? What we do is the vector y is unique. How do I solve it? Okay, so what is y? Like for every x, there is such a y that this one is equal to 0. Okay, so but we say this is additive inverse. Okay, how to show that this is unique? Okay, let's say there are two. Okay, which means x plus y dash is equal to also 0. Okay, so what this means, x plus x plus y dash, this both are equal. So now what we do is we cancel x from each side. So that will give us y is equal to y dash, or what we will get, cancel x from each side, you will get y is equal to y dash. Okay, so that's the proof of this y is unique. Okay, so we cannot have a different additive inverse. Okay, for x. So this concludes the proof of corollary 2. Now let's go to, okay, we name these things. Okay, so what we have been calling this 0 we call 0 vector, and this y we call additive inverse from now on. Okay, so now let's say we move to, okay, next theorem. This this okay. How do we do this one? Okay, 0x is equal to 0. Okay, so what I will do is 0x plus 0x. Okay, so this one is x 0 plus 0. Okay, now 0 plus anything is 0, so this will give us x 0. So this will give us 0x plus 0x. Now this and this you can cut off, so that this will be 0x is equal to 0. Okay, so now minus ax, this one is done, right? So now this, how do you do this one? Okay, mm, how do you do this one? Okay, okay, so what is minus a? Minus a is defined as additive inverse of a, right? So this a minus a is equal to 0. This is what this element is called, minus a, right? Okay, so what do? We do like this, to minus a. mm, what do we do? A minus a. Okay, this one is equal to 0. Now this into x like this will be this, right? So we'll get a. Now use distributive law, that this will be a minus ax, this thing is equal to 0, because 0x is equal to 0, that we have proven here. Okay, this one is the distributive law. In the like definition you can see vector space. Okay, so this one gives ax minus ax is equal to minus ax. Okay, so now you can do, like, I have proven one of them, right? This one I have proven. Okay, so to prove this one, what you will do is just same thing, you write like this, a minus a. Okay, uh, I will leave that as an exercise. Now let's go to C. A0 is equal to 0. Okay, so how do we do that? A0 plus A0 is equal to 0. Okay, and this one is equal to, no, how do we get this? Okay, you can do this. A0 plus 0 is equal to A0. Okay, and now what do we do? Use distributive law, so you can know A0 is equal to A0. Okay, now A0 and A0 cancels out, so we'll get A0 is equal to 0. Okay, from both sides. You can write this as if you want. Okay, so this concludes the proof of C. Okay, so that's it for this picture. Thank you.